by now you already familiarize yourselves with the basics of R, it's about time to start thinking of how you can have R find specific files in your machine's file system and manipulate them so that in a second step it will be able to import these files as appropriate R objects, meaning that it will take these files and then convert or transform them into objects that belong to one of R's data types, such as character vectors, or objects of a more complex data type, such as data frames that we will see in later videos. But before being able to import files into R, it's essential to understand the concepts of a file system and a file path, and also to navigate your file system with some basic R functions. And that is what you are going to learn in this video. Let's start off with some basics and break down the concept of a file system first. A file system is a set of files and folders of your machine that respects a certain hierarchical structure and that you come across every day when you open and work on your computer. All operating systems have graphical user interfaces that represent folders or directories as envelope icons that you can double-click on them and see their contents. By the way, I use the terms directory and folder interchangeably, since both folders and directories essentially mean the same thing. They are simply meant to contain one or more files or other folders. The folders and the files that live inside a specific folder can be thought of as nodes of a tree, as the one that you see here, where the folders are colored orange, and the white colored nodes underneath them are the files that you are used to see when you double-click on a folder. Files are leaves of the tree, meaning that there is no way that you can place any file inside them, or else they lead to a dead end. The tree that you see right now is also called a file hierarchy and is a valid representation of a part of a hypothetical file system. Tree representations, like this one, reflect the hierarchical structure of the files and folders in your machine. Of course, the whole file system is much more complex, since it includes a big number of branches and has many more files and folders that make its tree representation much harder to display on a single slide. That is why I simply omitted them and replaced them with the three dots. So, this tree then is a partial representation of the file system. A special place on the tree is its top node, also called the root folder, and is always signified with a /. The second important concept that you need to understand is that of a file path. A file path is a description of a path that reaches a specific node or branch of the tree from any other place on the tree. Knowing how to traverse the file system in R is important, since it helps us signify the path from and to any specific location on the file system that R should follow in order to find a specific file and read it. So, in other words, through file paths you give R directions as to where to find a file in your file system. Let's have a look at two paths. The first path, starting off from the root folder, goes all the way down to sub_testing_dir2 through testing_dir and sub_testing_dir1, and then ends up at the sub_testing_dir2. Following the second path here, you start from the root directory again, and then through the folders testing_dir and sub_testing_dir1, you reach at the place of the file test_file5. Now, how do you indicate a path to a specific folder or file in R, or in any other programming language for that matter? There are two ways of doing that. Through describing the path starting from the uppermost node of the tree, the root folder, or through describing it relative to a different location on the tree and not the root folder. The first way is implemented with an absolute path, and the second one with a relative path. So, for writing down the absolute path leading to sub_testing_dir2, you would first need to add the root folder that is always signified with the first /, then the folder that is within it, while the rest of the folders of the path that lead to sub_testing_dir2 are separated with more /. Notice the two different uses of the /. That is, the first use in the beginning of the absolute path that denotes the root folder, and the second use for denoting a separator between the folders. For understanding what a relative path is, it is better to first answer a very sensible question that a novice R user may have. What does it mean to give directions to R when I actually don't know where its starting point is? Is it always the root folder or some other place? In other words, you would need to know where the actual working directory of R is throughout your session, or else which place of your file system R has immediate access to. Let's head to the RStudio console and find that out. In R, you can find the current working directory with the getwd function. The returned output is a string that shows the actual folder in the file system whose files R has immediate access to. The current working directory, as you can see, is the folder sub_testing_dir2 folder. So the returned output is actually an absolute path. Now, let's get back to the second type of paths, the relative paths. Relative paths are paths to specific folders or files written relatively to some location on the file system other than the root folder, as I just said. So, you could define a path to a file relative to your current working directory. Let's have a look at a couple of relative paths on the tree that you saw. Let's assume that your current working directory is the sub_testing_dir2 folder, and you would like to describe the relative path to the file test_file5. In order to do that, you simply follow the structure of the tree. You first need to go up one level and find the branch sub_testing_dir1, and then go down again to find the file test_file5. The notation for going one level up is a double dot. Using a double dot in a path automatically transfers you to the folder above, namely to sub_testing_dir1. Then, you again have to use the / to indicate the next step to follow in the path. Since you already reached the sub_testing_dir1 folder, the only step that remains is to go down to test_file5. And you do that last step by simply writing down the name of the file you want to reach. Let's take a second example. Suppose you are again at the same working directory as previously, but now you need to go to test_file2. This time you know that you need to go 2 levels up, first through sub_testing_dir1, then through testing_dir, and then 1 level down to test_file2. From the previous example, you already know how to write down the first step going up, and no surprise, you need that here too. The second step is no different from the first one, though, which means that I need the double dot again. The last step is to go 1 level down after the last /, and I simply write down the name of the file I want to reach, namely test_file2. Let's get down to practice now and try to change our current working directory to other locations within our tree using absolute and relative paths. To make things easier for you, I created the files and folders of the tree you see within my file system, and I suggest you also create a file structure similar to our tree within a convenient place in your file system so that you can follow along the code of this tutorial. As you saw earlier, by using the getwd function, we found out that the current working directory is the one we've been using as a starting point for the relative paths examples. In order to change the current working directory, you need to use the setwd function. The argument that this function takes is a string with the path to a location that you would like your new working directory to be. So, let's say you would like your new working directory to be testing_dir, which means that you would need to go 2 levels up in the hierarchy. For this to happen, as you know by now, you should place 2 double dots in a row separated by the / that signifies the change in location. Now let's check out whether our new working directory is where we want it to be with getwd. Okay, good. Notice that for setting a working directory, you need to specify a path to a directory, as its name says, and not a file. A file is not a location that contains other files and cannot be a working directory. Let's change our current working directory back to the previous location 2 levels down. That means simply that you write down sequentially the folders underneath, one after the other. And if you want to check out the effect of the change you made, you can use the getwd function again. For setting your new working directory using an absolute path, you simply need to write down all the folders starting from the root folder down to the one you're interested in. So, for setting the testing_dir folder as the working directory, I would have to write down the following path as the argument to the function setwd. The next step for you is to be able to programmatically ask for information related to the working directory. For instance, for listing the files and folders of your working directory, you can use the list.files function. You can also list the contents of a different folder on the tree without changing your working directory by simply using relative paths. For instance, let's say I would like to see what the contents of sub_testing_dir1 is. To do that, I write the string with the relative path of the folder I would like to check its contents. Going one step down means to simply include the name of the folder sub_testing_dir1 as the argument to list.files function, as I do here. If you only need to see which folders your working directory has, ignoring the files in it, you list them with the list.dirs function. Here, as expected, the only folder included in testing_dir is sub_testing_dir1. Check that out on the tree that we saw earlier. The output is a character vector whose members are the paths of the folders it contains. Notice that the first member of the return vector is a single dot. A single dot represents the current working directory. You don't need to know more about the single dot, since it's related to the way that the file system is handled internally. For now, make sure to interpret the single dot in the beginning of a path as the current working directory, relative to which the rest of the path can be described. Let's move on to asking for information about specific files within a folder. And let's remind ourselves once more the contents of the working directory with the list.files function. Now, with the file.info function, you can ask for information about specific files, as I do here, with the test_file6 file. The output includes lots of useful information. Let's go ahead and see them one by one. The size indicates the file size in bytes. Apparently, since I created empty files for the purpose of the video, test_file6 is empty and has size of 0. The isdir colon indicates whether it's a folder or a file. We got false since it's not a folder. The mode is an octal number that indicates the file permissions for all potential users. This number specification has its roots to the Unix operating system and the way that the files have been treated historically in Unix-based systems. I suggest you go ahead and look up for how to set file permissions if you are interested, especially if you are working on a team that share the same computer or network of computers. The M time signifies the last modified timestamp, meaning the last point in time that the file was modified. The C time indicates the timestamp that the file was created, while the A time signifies the last time it was opened. The last 4 columns describe information about the owner of the file, the group the file belongs to, and as said just a minute ago, it applies to shared accounts or computer networks. I think there is lots to process for you now. Take your time to practice file paths and how to navigate your file system programmatically using R. And next time you're going to see how to create, delete and move files in your file system with R. And of course, if you like the content of these videos, don't forget to subscribe to the channel to get notification when new videos are released.